All right. You're doing great. Nice, Willie Blue. Yeah, I'm doing pretty good myself. Just chilling. I'm actually in finals week right now in school, but it's actually going pretty well. So I'm having a time. Definitely having a time. SWT, how was the concert? I know you were going to see that really awesome K-pop star, right? Super attractive guy. It wasn't Harry Styles, unfortunately, but I know it was someone else. It was amazing. Nice, 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 nice. At the gym, shoulders and core today. Shoulders and core. I usually do legs, then shoulders, core, then back and biceps, and then chest and triceps. Nice. Yes. Nice, nice, nice. What's up, Ashley? Good to see you too. All of you are the survivors of the boot camp. Look at this. So we only have a few survivors so far. Ashley still going strong. Bruce going stronger than ever. BZ, of course. Snowmobile still hanging in there. SWT, the legend, and Willie Blue, of course, still at it. I'm pretty impressed that all of you have made it this far. This stuff is not easy at all, and it takes a lot to stay focused for 4 weeks. But hey, you're doing it. All right, so let's actually get started. So I was saying this before to the few other people that were here. Welcome, Bruce, Ash, Snowmobiles, for thanks for coming in. But today's actually gonna be not that bad. It's gonna be pretty easy. At least I think it's gonna be a lot easier than previous days. So if you're feeling stressed about a lot of the work so far, this one's actually not that bad at all. So what we're gonna be talking about today is the beginnings of Chapter 5. So if you remember, in Chapter 4, we actually left off talking about the NFT contract. We're going to take a quick pause from that, and we're going to instead start with Chapter 5. So let me load up a totally new playground example so that we can work with this. And we're going to be talking about day 1 and day 2. Day 1... sorry, excuse me. A little bit sick right now. But day 1 is the pre and post conditions and also events. And day 2 is talking about contract interfaces. So they're not, they're not heavy topics, but they are going to be extremely important for the NFT contract, which is why we're taking a pause from that for a second. All right. So, sorry, I'm probably going to be coughing a lot. Okay. So the first thing that we want to talk about is the panic keyword, right? So we've actually gone over panic a lot together, but let's just run a quick example of what panic actually does. So, if we have a program, this could happen in your transaction, your contract, or your script. We're just going to do it in script for now. But if you have, like, for example, let A equals 3, right? And then you say, like, okay, we're going to, like, log A, and then we're going to, say if A equals 3, we're going to panic, right? And say, like, problem, right? And then we do something afterwards, like we log A plus 1, right? So what happens if we run this program? Well, obviously it's going to panic, right? Now, what panicking does is it aborts everything. So you'll notice that A didn't even get logged here, right? Because we ended up panicking. So it's a really important point to know that when you see a panic in a program, that means that everything that happened in that program gets completely reset. So if you, run a transaction and that transaction sends an NFT, deposits an NFT, withdraws $1 million, and then destroys $1 million, and then panics, none of that happened. So it completely reverts everything that happened inside of a transaction. So it's really important to know when we talk about the panic keyword. Now, the reason I'm mentioning this is because panicking is going to come into play when we talk about pre and post conditions. So if we actually go into a contract, let's delete some of this base code. We don't need a lot of this. So if we delete this base code, let's go ahead and make a function called like public function test. Okay. And inside of here, we're going to take in a variable called A, and it's going to be an integer. And inside this precondition, what a precondition does is it runs at the very beginning of this function. So when we call this function test, this is the first thing that's going to be run. Now you may be saying like, well, how is it different from just like putting things here? It's different because pre is basically like a helpful way to panic if something is wrong. So what we can do, for example, is instead of a precondition, we can specify some things that have to be true or else we panic. So in this precondition, if we say a must equal 5, then what we can do here is we can say a equals 5, then this little, what is this, a colon, and then we can put a message here. And this says like a was not 5. So what this means is you put a condition that has to be true, and if it's not true, it panics. Now, you may be asking, well, like, how is this different from, like, if we commented this out right now, or if we just got, like, here, let me make another function here called test2, and make another integer here. Like, how is this different from me saying if a equals, or if a does not equal 5, panic, right? And then to say, like, a was not 5. So the truth is, these two functions are exactly the same thing, right? This is saying a has to be 5 or we're going to panic. And this one's saying if a is not 5, panic. They're the same exact thing. The only difference is that this one is more human readable. Now remember, it's one of the, core principles of Cadence that we make our code readable, right? That's what Cadence prides itself on, is being readable and easy to understand. So this sort of thing, you see this a lot in contracts. This is not good practice. If you see this in a program, this usually means that, the person has either, just started developing or isn't too experienced with Cadence yet. You always want to make sure that your code is humanly readable. And even though, you may be asking, well, why do I care, right? I don't care if it's human readable. Well, it is really important that as developers, we're conscious of our code, because a lot of the times, we'll develop some smart contract code that has to deal with money or trading or stuff like that. And, a lot of the average user does not know a lot about, like Cadence code. And so if we can make it easier for them in any way to understand what our code is doing, if, so that they're not scammed, we should always make sure that we do that. So this, I would never do this. You always want to make sure that your code is in a nice format, so you have this precondition here. And I'm not saying it's not okay to panic. So BZ saying, haha, I've used panic a lot. It's totally okay to panic in other parts of your program, but in every case, you always want to make sure you're doing your best to make it humanly readable. So that's what a precondition is. Now, what we can also do is let's just have like a variable here. So actually, you know what? Why don't we run this function first, just so I can prove to you that something happened. So in this function, we can log a. Okay. So if we deploy this contract, let's go to a script here, and let's import hello world from OX01, and then inside of here, let's refresh the page. Oh my god, playground, woo! So in here we can do hello world dot test, and let's pass in 4, right? So if we pass in 4, then it says, hey, a was not 5, right? So precondition failed. Now, for the record, this is another reason why preconditions are so cool, is that it actually tells you that a precondition failed. So it's not going to just give you the panic message. It's going to tell you specifically that a precondition failed. So it helps you as the developer go back into your code and look for the precondition to say, oh, here's a precondition. It's definitely this one, right? So it's definitely this is what's giving us a problem. So if we pass in 5, though, and we execute this, then it is all good, or at least it should be, if the playground wasn't trying to constantly ruin my life. But it's 5, right? So cool. All right, sorry, I just had to cough again. Okay, so that is precondition. So not bad, right? Actually, pretty easy. Yeah, pretty easy, right? So that's preconditions for you. Now post conditions, and I also I want to make sure that while we're doing this course, I also give you like some insights about what I have found as a experienced Cadence developer. Preconditions are extremely, extremely popular. You see them everywhere. They are always used, like always. Post conditions are literally never used. I have never in my life seen someone use a post condition in a real example. But with that being said, I still think it's really cool, and so I think it's worth showing you anyway. But, I do think part of this course is sort of like giving you like little insights on what, you might experience as a Cadence developer. You'll probably never end up writing post conditions, but hey, why not teach you something new? So let's go to post conditions. So Do I have, okay, yeah, so I do it right here. So what we can do in this contract is let's have like a public var count, and let's have this be an integer. And inside, let's down here, let's initialize this this count. Let's go up here and say self.count equals 0. So we're going to start it at 0, right? Let's just get rid of this precondition. So let's get rid of all the parameters here, and let's add a post condition. So one thing I want to mention is that even though post condition gets run after the function completed. So when you have a function, you know, let's say it does a bunch of stuff, this post will get run afterwards. But it's a little tricky because you still define post condition at the top. So in here, if we like log 3 or log 2, we like log 3, we say self.count equals self.count plus 1, right? All of this is going to happen, and then this is going to happen. So even though post comes before, it's still going to get run after. So just make sure you know that. But yeah, a post condition is going to run after this code, right? So what we can do in the post condition is we can make sure we have some parameters, or we make some restrictions on what the resulting impact of this function is. So let's say that, you know, our count starts at 0, right? And we want to, you know, this test function, we can call it like increment. So this function will increment the count after every call. So it'll add 1 to it, it'll add 1 to it, it'll add 1 to it, right? It'll keep going. But what if for some reason we wanted to stop the count at 5? Well, we can say self.count has to be less than or equal to 5. And if it's not, say we can't let the count go above 5. Okay? So if this happens, we'll be able to run this code 5 times until it gets to this number. So if we deploy this and also every time we can just log self.count, so we have like a helpful understanding of what's going on. So we deploy this contract, and then in the script, we say hello world.increment. Okay? And if we refresh this page and execute, you'll see it's 1. Now it's, oh, well, it's being weird. Okay, well, it's just being weird. Oh, playground. Okay, so we execute. What? There's no ever increment. I spelled that right? Okay, I think it's just being weird. Come on. Okay, well, it's being annoying. I don't know why it's being like this. Because it should be deployed. Right? Okay. Okay, well, the playground hates me for some reason. Oh, well, maybe, okay, so 1. Yeah, I don't know. It's being weird. God, wow, the playground's so buggy. This is terrible. Look at that. It didn't even update the count. That's so bad. Oh my god. Well, this makes it impossible to teach. But you get the point, right? So yeah, I could use the emulator. That's a great point, BZ. Should I do that? But I don't want to overcomplicate this, though. Because I want to make a whole other bootcamp about that.
Yeah, but somehow, like, you know, it doesn't matter that they learn how to use Playground if we can't use the Playground anyways. Like, it has been buggy for so many months, even when I started learning.
It's so bad. Yeah, okay.
So
So, all right,
if
so
they
we're
don't
gonna...
want to do something, they would need to learn it anyways, like VS Code and the emulator.
Yeah.
And how to scripts. I know it complicates more stuff, but
No,
yeah.
I agree. I mean, the thing is that today's content's actually not that confusing, so we can actually spend some time. So I'll take a vote. Who's okay with learning how to use the emulator? Because this is just like, we can't even use this.
How do people vote?
Should we do like a thumbs up?
Yeah.
All right. So keep in mind that this is like, I haven't prepped for this, so we'll see how this goes. But let's just in here, let's make a directory called, let me turn off this note. Okay, let's make a directory called, I don't know, emulator test, okay? cd into emulator test. So I'm going to open this in VS Code, and we'll just, you know, cancel out the playground because it's just too buggy. Screw you, playground. You're an a-hole. Okay, so hopefully this should work. So we have an empty VS Code here, right? So you can use any, like, really any code editor you want. And so inside of here, we're going to, we have to first initialize the flow JSON. So the way that you do that, by the way, just for the sake of like learning purposes, you first of all, you have to install the Flow CLI. So this is what allows you to run the emulator on your local system. So you go to docs.unflow.org /flow CLI, you click on these steps, and then you just, for Mac, you run this line. I wouldn't run this line. I would just run this line. For Linux, you run this line, and for Windows, you run this line. So all you do is you copy it, you go to your terminal and you paste it, but I've already done it. And once you do that, you should be able to type flow version, and that will give you like, if you see any type of version here, you're good to go. So yeah, and then once you do that, you can type in flow init like this. And if you click on enter, it'll actually create a flow.json for you. So if we go back to our thing here, boom, we now have a flow.json. So that's really helpful for us. So what we can do now is we'll have to open up two little pages here. I think I called it emulator test. And so in one of these, you'll have to start the emulator. So what does it actually mean? Well, an emulator is almost like a local blockchain. So when you're on the playground, they're running an emulator for you, right? So the playground is in itself like a little local blockchain. We're gonna run a local blockchain on our computer. So the way that you do that is you do flow emulator start, and then what I always do is add this -v flag, -v. What this allows you to do is it allows you to see logs inside of your scripts and transactions and contracts. So it's extremely helpful for debugging. By the way, the Flow Playground does this by default, but it's really helpful for when you start the emulator to remember to put -v because you can see logs. So if you start the emulator, you'll see it actually like starts up some cool, some jazz here. And so now the emulator is running on our system. So what we can do is we can make a new file called, what is it called? Hello world.cdc. And so this is a contract. I put the .cdc extension, and one of the things you're going to need is you don't need it, but if you go to the docs here, so if you go back to the docs, you can click on VS Code extension, and if you go, there's a lot of random stuff here. I don't know why it's so random, but once you install the Flow CLI and you type flow version like I showed you earlier, and it gives you this right here, you can actually copy and paste this line. So flow cadence install VS Code extension, and that will automatically install this cadence extension on your VS Code. So I recommend using VS Code for this.
Your screen is freezing, Jacob, because people can't, or I can't see.
Oh, is it freezing?
Yeah, because nothing is happening on my screen, nor will it lose.
Oh, really?
I don't know if this happens for anyone else. Like, try to open Flappy Bird. I can't see anything.
Oh, it's frozen. Yeah, oh, that's weird. Huh. I don't know why it's freezing.
Just close and reopen the screen. It should work.
How's it now? Better?
Yeah, now we can see VS Code. Yeah.
Okay, yeah. So, just let me know if it ever stops again.
Yeah.
Is it still good?
Yeah, we're good.
Okay, perfect. Thanks, PC. Sorry about that. Yeah, so basically, I don't know how far away you got lost, but I was just showing you that. Did you see me set up this whole emulator?
Yes, it was just like the copy pasta thing, like how to install the extension, I think.
Oh, okay. Got it. Yeah. So, so once you start the emulator, I was showing you how to get the VS Code extension. You go to docs.unflow.org /VS Code extension and just copy and paste this line right here. And if you copy that into your terminal, I'm not going to do it. Oh, that's the wrong one, but I'm not going to do it because I've already done it. It would be this one right here. So you just copy that and click enter. It'll actually add this extension right here, this cadence extension. And what this will allow you to do is it'll give you syntax highlighting. So if I type in like public contract, hello world, you can see it's actually like highlighting the text for me, which is awesome. So cool. All right, so now that we've done that, we can actually, let's just put all of our code in here now. So let's do, for example, I don't know, let's do pub function test, and we had the post condition, right? So we go in here, let's add the post condition again, and I think we also had a number, so public variable number is an integer. And if we go down a little bit more, we need to initialize this number equal to 0. And also look how much nicer this is. Like, it's giving me like auto completion and everything, and this is because I have the extension, so it's super nice. I know it gives you like errors too, right? Like if I get rid of that, you'll see it gives me an error here. So the extension's like incredible. Much nicer than the playground ever would be, right? So yeah, so inside a post condition, we can say, let's say self.number is less than or equal to 5. Otherwise, we say we can't let the count go above 5. All right. And then here we just say self.count equals self.count plus 1. And then log self.count. I think I meant to make this count instead of number. And this should be increment, right? Okay. And this should also be count. Okay. Cool. So here's our little contract that I had in the playground, but we got interrupted. So here we are, right? So now to make a script, we can actually make a new file. And let's call this, script. You can name this whatever you want. I'm just calling it script. Just like that. And if you do that, then what you can do is you can do public function main. Let's open that up. And I think this works. I hope it does. You can just import hello world from, and then instead of doing like OX01 or whatever, you can actually do /hello world. Like you can reference it based on the file paths. So you see that's what I've done right here. And then inside of here, I can do, let's just run. Oh, man, this needs to be a transaction, right? Because we're incrementing. Oops, I'm an idiot. So let's just do transaction.cdc. Let's make the new transaction. This is all just set up. You've all seen this before 1,000 times, so I'm not going to explain this part, but you get the point. And then we can also import hello world. Okay, cool. So then inside here, we can do hello world dot increment, right? So and look, it gives us that it gives it to us for automatically. So what I want to try to do, actually, like, let me try this first, just so that I know this doesn't work, but let me try. So I think if I click this, what happens? Okay, so it actually loaded up. That's pretty cool. And then what happens if I click this? Okay, that's what I thought. It doesn't work. Okay, yeah. So the extension's kind of broken, but it's fine. Wait. Oh, interesting.
Yeah, I think you just deployed the contract by clicking.
Yeah, well, this back in the old days when I was first starting Cadence, the VS Code extension worked, but I think it's since broken, which kind of stinks. But that just means we have to use the command line, which is kind of rough, but it's okay.
Still better than the playground.
Still better than the playground, true. So what I just did was I started the emulator, and now we want to deploy the Hello World contract to our blockchain, right? So in order to do that, we need to go to flow.json. And by the way, if you're getting completely lost here, the point of this lesson is not this part, so it's okay if you're lost, but I hope this helps at least somewhat. So in order to deploy the contract, you have to go in your flow.json and you have to put the name of the contract in quotes. This is all in the contracts object. You put the name of the contract and then the file path to the contract. So hello world points to /hello world.cdc right here. And then in deployments, you put the blockchain type. So either like emulator, testnet, or mainnet. So we're on emulator, open another object, and then you have to put in an account. Now, when you type it in Flow init, it automatically gives you an account. So you just put in the emulator account here, because that's what it's called, right? So emulator account. And then you open up an array, and in here you put the contract names. So all of this like confusing stuff is basically just saying we want to deploy the Hello World contract to the emulator account. That's all that this is doing. So now that our emulator is set up, we can go into a different sort of terminal here, and we can type flow project deploy, and hopefully if everything works well. Okay, of course it didn't. Oh, it's already deployed. Oh, because the stupid this is still running. Let me cancel that out. Okay, so let's just reload this. Okay, so what you would do is, you do flow project deploy, and then look, it's this deploying one contracts from account, whatever, emulator account, and it's green. Yay! So all contracts deployed successfully. So Hello World was deployed to this account. Awesome. So inside of our transaction, let's go ahead and execute this transaction. So in order to do that, you say flow transactions send. And I think, and then the file path to the transaction. So /transaction.cdc. So boom, sealed. It went through. It worked. And hopefully we get logs. Yeah, so look, we're actually getting, because we put the -v flag right here, it's giving us logs. So look, it logs 1. Now if we run this again, it logs 2, right? If we run it again, it should be 3. Let's see if it's at 4 now. Okay, now it's at 4. Let's run it again. And now it's at 5. Okay, now this is the whole point, is that it should give us a problem, right? So the post condition now, it's going to add 1 to it. It's going to be 6. And then it's going to say 6 is not less, 6 is not less than or equal to 5. So if we run this again, we should get problem, cadence runtime error, post condition failed. We can't let that count go above 5. Self.count is less than or equal to 5. It gives the error here. So round of applause to me. Wow, what a teacher. On the spot. Boom. So there we go. So the post condition fails. Cool. So is everyone okay with pre and post conditions? And I have a little bit more to say about post conditions, but yeah. Also, yeah, that was fast. Sorry if I lost everybody. Okay. So we're going to do a little bit more about post conditions. So let's go ahead and get rid of all this increment stuff. Actually, I want to know. Okay, yeah. So actually, no, we're going to keep this for now. Okay. Cool. So we're going to keep this increment function, but we're going to do some cool stuff in our post. So instead of just logging the count, what we're going to do is return it. So we're going to return the count. So this is just to show you, so we can return the count and add a return type here. Oh, this is an int, I think. So one cool thing that we can actually do in post conditions is we can use a keyword called before. So let's get rid of this condition. And what we can do is we can say before self.count equals self.count minus 1. We didn't add correctly. Okay, so what the heck does this mean? Well, in post conditions, you can use a special keyword called before. Now, what before does is it accesses the value of whatever is inside of it before any of this function was even run. So if we think about it, right, let's say what happens when this function is called. So step 1, the count is 0, right? Step 2, we go in the function and add 1 to it. So, step 3 is that the count is now 1, okay? So it's going to do that. And then it's going to say, okay, in the post condition, was the before value of self.count, which should be 0, equal to self.count, which it is right now, which is now 1, minus 1. So 0 equals 0. We're all good to go. So this works totally fine. So we didn't even need to add this return here, but just here. So if we run this transaction, first of all, we have to redeploy our contract because we changed it. So let's go ahead and redeploy the contract and then run the transaction. And you'll see that everything is totally fine. Okay. But if we were to go back into our contract here and say self.count, like, I don't know, plus 15, right? This obviously will not work. So if we just restart the emulator, we deploy the contract, and then we run the transaction, we should get a problem. Transaction error, cadence runtime error failed. Post condition, we didn't add correctly. So there's the problem. So we can use this before keyword to get the value before it was actually run. Now, one last thing, and then I will officially be done, is we can access another value called result. So result is a keyword we can use to access the return value. So in this case, what we can say, just to combine both concepts, we can say, okay, we want before of self.count, so 0, to equal the result, which should be 1 because we're returning it here, minus 1. So if we combine both of these concepts, we redeploy the contract, or the emulator, deploy the contract, and then run the transaction, it's totally fine. It's sealed. We had a green check mark. Everything is good because, yeah. All right. Oh, you know what I can do, BZ, if you want?
Oh, you really dislike the VS Code
I hate it. I hate it. Yeah.
Okay, I use it a lot. Like,
really?
yeah.
Here. There we go.
I would say though, when you taught me, how to use Flow blockchain in the beginning and use Playground, right?
Yeah.
Like the first time I had to do stuff on my own and use Playground. It was so buggy and so painful to write an NFT smart contract. And then afterwards, after I've finished writing it all, you tell me that, hey, VS Code exists and there's this extension that
Yeah.
that actually yeah. So I actually think it's quite good that people learn this early rather than, going through Playground and trying to write a real smart contract.
You know what? You're totally right, BZ. I want to find, because the only reason I like the Playground is because we don't have to I don't have to run these commands every time. But I 100% recommend, while I do teach all of you in the Playground, all of my actual coding is done in VS Code. I never use the Playground besides teaching. So BZ, I'm honestly glad you brought this up, because maybe in future boot camps I'll mention this early on just to give people the option, but I'll still teach in Playground.
Yeah, I think Playground is definitely much better to not making it intimidating, in the beginning. But I think it's quite good if in every course that you will transition to the real stuff so people can use it. Yeah.
Yeah, no, you're totally right. Yeah, 100%. That's actually a great point. And in the next bootcamp that we do, where I'm going to be teaching all about FCL, this is an introduction to FCL, because you're learning how to run the emulator and stuff. But in the next bootcamp, I'm going to teach everything about emulator and testnet, and you'll get a much better understanding of what all this is actually doing. But yeah, for now, we're just going to stick with the cadence. But yeah, thanks, BZ. All right. So how's everyone doing? I'm going to put another thumbs up in chat because that seems to work pretty well. Is everyone good with pre and post conditions? I probably went on too long about it, to be honest, because it's not that crazy of a topic, but okay, cool. So seems like people are good. Sweet. So the next part of this, again, it's not too difficult at all. It's a concept that we've sort of already learned because we've done resource interfaces. So this time we're going to be talking about contract interfaces. So we're actually not going to use any transactions or scripts anymore. So I can just go back to this. So let's start coding in our VS Code. So why is this so sorry, I'm okay, yeah, here we go. So what we can do now is so let's actually just clear this contract, and because we're gonna start back from zero. But if you remember resource interfaces, so just to go over that again, we had a public resource called test, and then here let's say we had an ID, right? Pretty simple. We initialize this ID to equal, I don't know, self.id equals self.uuid, right? Pretty simple stuff. And then a resource, let's also add a name. And say self.name equals Jacob. Then what we could do is we could add a resource interface, pub resource interface, called iTest. So it's an interface. And we just put the ID in here. So what this says is if we take this resource interface and we make tests implement it, so we put iTest on it, that means that this resource can be restricted to this resource type now. So there's a few things that are meant by that. One, test now has to have an ID. Now, of course, right now it does, but if we were to get rid of this, look what happens. It gives us an error. It says resource test does not conform to resource interface iTest, right? So we need to have the ID there. Now, the other cool thing is that we can scope a resource to just the iTest. And we saw a great example of this when we were doing the NFT contract, right? Because we only wanted to expose the deposit function and not the withdraw function. So we put deposit in here and then had it implemented, all that kind of stuff, right? Now, the reason I bring this up is because contract interfaces are pretty similar, except contract interfaces are really only used for the first one. So contract interfaces are basically requirements that your contract has certain stuff in it. And the reason for that is because of something called a standard. Now, a standard is a really important concept on Flow, and honestly, any blockchain that you go to. If you have any experience with the Ethereum blockchain, you may have heard of stuff like ERC 20 or ERC 721. The ERC 721 is another name for the non-fungible token standard on Ethereum. And the ERC 20 standard is the same thing as saying the fungible token standard for something on Ethereum. Now, on Flow, we just call them non-fungible token standard and fungible token standard because we're cooler. But, this is going to be really important when we, wrap up our NFT contract, because we're going to need to implement the non-fungible token standard. So before we do that, though, let's learn a little bit more about what contract interfaces actually mean. So let's get rid of this resource stuff here. And we're going to open up a new file called hello interface.cdc. So with contract interfaces, they're actually an entirely separate contract. So they don't go inside the contract. They're completely separate. So, you would do public contract interface, and we call it hello interface. And inside of here, we don't actually implement anything. So, if we have like a public var number here, that's an integer, right? If we initialize this, it's going to give us an error. Because contract interfaces are not allowed to have init functions. So you can't put init functions in contract interfaces. And another thing is that if you have like a function here, so a public function like increment, you cannot implement it. You can't open up these brackets, so it's going to give us a problem. Cannot implement function in contract interface. You can only have the definitions. Now, you may be wondering, well, like, what's the point of this then? And the point of this is that it specifies a set of requirements that our contract has to have. So inside of hello world, we can actually import hello interface from /hello interface.cdc. And we can tag it onto the contract itself. So very similar to how we do it with resources. Now we get a problem. And it says hello world. Contract hello world does not conform to contract interface hello interface. And then, well, it's pretty simple. It's because we don't have these two fields here. So if we take these two fields, what might be helpful actually? If I do this split screen, I think this is actually a great idea. Boom, split screen. So here's the contract and here's the interface. So if we take what's in the interface and let's paste it in here, now, of course, in the actual contract, we have to, initialize these. So we have to make the number like equal to, 0, and we have to implement this one as well. Okay, so now the contract is fine because we implemented everything the contract interface told us we had to implement. All right, now, one cool thing about contract interfaces, though, is that even though, so remember, when we open up these brackets, it gives us a problem, but what we can do is we can put pre and post conditions here. So this is why I taught you pre and post conditions, is because even though we can't implement the function, we can put these here. So let's just say, let's add a post condition, and instead of here, we're going to say the post condition is that self.number or self.number equals self. Equals self, or before self.number plus 1. Otherwise, we're going to give an error that says you did not increment the number. So, and look, now there's no error. So the really cool thing about this is that in our standard or inside of our interface, we can say, okay, the contract has to have an increment function, right? So we're like, okay, it has an increment function, but in addition to that, the person that's implementing it has to make sure that they take self.number and make it equal to the before value plus 1. So if I was like an idiot and I was implementing the contract and I did this, like 10, it's not going to give me a problem right now. But when I run this when I run this function, it's going to give me a problem even though there's no post condition inside of this contract. So let me go ahead and actually do that. Let's show that to you. So let me just go ahead and configure some stuff. I'm gonna do this very quickly because I don't want to waste time on this. Okay, and let's just go ahead and deploy this. Okay, so I'm going to start up the emulator again. Boom, and I'm going to deploy the contracts. So they're both deployed. And now what I'm going to do is I'm going to call increment on hello world again. So I believe this should do that, right? Now, remember what's going to happen. I'm going to call increment, which calls this contract. It's going to go in here, it's going to add the number by 10. And even though there's no post condition here, it's still going to give us a problem because the hello interface is, restricting what we can do. So if we run the transaction now, boom, we have a problem. So you did not increment the number. That was the problem I gave here. So does everyone see how we got a problem even though we didn't actually put a post condition here? We put it over here, and it still gave us a problem. Is everyone okay with that? I'll put a nice thumbs up. All right, Willie Blue's good. BZ's good. Snowmobile's good. Nice, nice, nice. Biggie Dude is good. Nice. How about SWT? Are you doing good? Ashley, oh, you're good. Good, good, good. Snowmobiles, you're good. Generous Kid's good. All right, seems like everyone is pretty much good. Awesome. So yeah, that is why pre and post conditions are pretty cool. And by the way, this is also true for resource interfaces. By the way, in a resource interface, you can't implement your functions, but you can use pre and post conditions, which we'll see in a bit. Okay. Now, the one last thing I want to talk about is something that this is probably the most confusing topic, which is resource interfaces inside of contract interfaces. Things get a little weird, and I'll show you why. So inside of our contract interface, I'm going to add a resource here. So I'm going to say public resource NFT. Now, of course, I can't, well, actually, no, I can. So inside resources, you can initialize some stuff. So let's say we want to have like a public let ID. We can put an ID here, but, again, we cannot initialize it, right? Because that's not the point of a contract interface. It's giving us a problem. Let me reload this. Please. Okay, yeah, so there's the problem. Okay. So we can put some fields in here that we want, but that's not really the main point. The main point is that in the contract interface, we can have the resource itself and a resource interface. So this is one of those things that's like super confusing, but you never like really have to worry about this. You kind of sort of figure it out on the spot. To be honest with you, I've been developing on Cadence for 2 years now, and every time that I deal with like a resource interface in a contract interface, I get confused every time, and I just like figure it out. So you don't have to like have this memorized. You sort of just go with the flow while you're building it. This is more just helping you understand contract interfaces because you're going to have to implement the NFT standard. So inside of this resource interface, we can put an ID here, okay? Just like that. Now, if we put this resource interface on the resource, boom, we're good. Now, and remember, okay, it's kind of weird, but all I did is inside the contract interface, I took the resource interface and put it on the resource, right? So that's awesome. Now, the main point is that inside the actual contract, you'll see, first of all, we're getting a problem that hello world does not conform to the contract interface. If I go down here, I have to make an NFT resource. And you'll see, look at this problem. So resource hello world.nft does not conform to resource type requirement hello interface.nft. So it's saying this resource right here is not the same thing as this resource. And well, it's not because we forgot the ID field. So let's go ahead and put the ID field and we have to initialize it. Okay. And oh, now there's another problem. So resource hello world.nft is missing a declaration to the required conformance to the resource interface. So all that's saying is that, hey, inside of here, we forgot to, put the INFT on this. Now, the most common mistake is that people will take that and be like, oh, okay, I forgot the resource interface. So they'll go ahead and they'll add it just like that. And then they'll put the ID in here, and then they'll do all this stuff, and then they'll add it to the resource, and they'll go, wait a minute, why am I still getting a problem? What is wrong here? This is so weird, right? People are like, oh, but I did everything right. I copied it exactly. And let's read the error message here. It says, the resource hello world.nft is missing a declaration to the required conformance to the resource interface, and then look at the type. It's saying hello interface.inft. Okay. It's not talking about this one. It's talking about we need to actually implement this thing right here. Now, this is a very confusing thing to understand, but it's really important. It's that inside of the implementing contract, we don't want to implement this resource interface. We want to implement hello interface.inft, and now we're all good. Okay. So again, it's really confusing, but the thing is that look over here. So inside of the contract interface, it's saying, I'll write it out in words. So this is saying, we need a resource called NFT, right? Check, we already did that. We need a resource called NFT that implements the INFT resource interface. Now, it's not any old resource interface. It's specifically INFT, which is pointing to this right here. So in our implementing contract, we need an NFT that points to INFT, which is defined in this contract. So you can't re-implement it over here. Okay, so that's a really important thing to understand. And, you know, what goes along with that is also the idea that inside of a contract interface, you know, you have a variable, you have a function, you have a resource, you can have all these different things, and you have to copy all of those over to here. The one thing you do not ever have to copy is a resource interface. So if inside of a contract interface, if you ever see a resource interface, you never copy those over. You can always keep them here. And that's pretty much all there is for contract interfaces. And what I'll do is for the last part of this video, I'm just going to show you the non-fungible token standard, and that'll be it. How's everyone doing? Super lost or doing all right? And I'll show you an example of the actual interface, but just want to make sure everyone's doing okay. Oh, everyone's good? Oh, that's good news. Oh, yay, I'm so glad. Okay, that's awesome that everyone's okay. Yay. All right. So cool. So actually, you know what? Why don't I show you what I wrote for Float? So I'll show you actually a contract that I wrote. Let's go ahead and do that. And it also implements the non-fungible token standard. And by the way, how cool is this that you're probably going to be able to understand a pretty complicated contract now? So inside of here, let me actually get the contract for you. Actually, that's not worth it. I don't want to confuse you too much. Let's go back to the base one. So here's non-fungible token. And for this one, we can go to the playground because we're not gonna actually run any code. But let me just copy and paste some stuff here. Change of plans. I'm going back to this plan. Okay. And then we just need one more contract. This doesn't matter, but hold on. Metadata. That's it. Okay. If we go back here, it should be good now. Yeah, okay. So let me show you side by side a example of the non-fungible token interface and an actual contract. So what I showed you before was a very easy example. This is a more complicated example, but I think you should be able to understand it. And we're going to spend the entire next lesson on this too. So let's take a look at our code here, right? So this is a contract interface called non-fungible token. So this is the same thing as the non-fungible token standard. So every single contract on Flow, every single contract that wants to be an NFT has to implement this standard. So they have to, look on the left-hand side here, you'll see this is an example NFT contract that was given by the Flow team. You'll see it implements non-fungible token, right? So let's look at the stuff we need to have. We have to have a total supply. Do we have it? Boom. Check. We do. We have to have an event called contract initialize. Do we have it? Check. Boom, we have it. What about withdraw? Do we have it? We have withdraw. We have deposit. Boom, deposit. And yeah. So one last thing. I totally forgot to talk about events, but they're not a complicated topic at all. Events, what they basically are, is they are ways of communicating to the outside part of the blockchain. So they're ways of having something happen inside your contract and telling people out in the real world that something happened. So here's one example of this. We declare an event by saying public event withdraw. And this takes in 2 parameters. It's almost like a function call, but it takes in parameters. That's all it does. It takes in an ID and a from. So who are we withdrawing from? It's an address, right? So if we scroll down here, stick with me. I know it's okay if you don't fully get all this yet, but you can see that in this withdraw function, we emit, right? The keyword emit withdraw. And again, withdraw is defined up here. Right here. So public event withdraw, it takes in an ID and from, and we go to where it's actually broadcasted. It's broadcasted right here. And boom, it takes in an ID, which is like the token.id that we're withdrawing, and a from parameter, which is who we're withdrawing from. So in this case, we're withdrawing from self.owner, which is the owner of this collection, and then their address, right? So what this will do is this will tell the outside world that we just withdrew a NFT, right? Which is really cool. Now, let me quickly show you why this is so powerful. There's a platform called Grapple Io. I'm not sure if any of you have actually heard of Grapple, but they are a really powerful service, and their sole purpose in the Flow ecosystem is to take events that are emitted from the blockchain, bundle them up, and broadcast them to users. So one example of this is at find.xyz. I'm sure all of you know the Find project. If you click on live feed, it says waiting for feed data. What it's actually doing is behind the scenes, it's asking Grapple, look, it's powered by Grapple. It's saying, hey, Grapple, can you get me all the information of all the events that happened? And these are all events here. So boom, moved, that's an event right here. Name registered, that's an event. Someone registered a name. Listed for auction, that's an event. So you can imagine that like in the contract, there's an event called like public event listed for auction. It takes in like an ID maybe, right? An ID, which is a UN64, and then maybe like a price, which is like a UFIX64. And then somewhere in the contract, I don't know, they do like emit listed for auction, and then they pass in the parameters right here. So like the ID was like 10 and the price was 15, right? So you sort of get the point, right? But that's what events doing, is they talk to the outside world. And yes, Calcoin is totally right. So if you go to actually floats.city and you go to the .live page, so this is powered by Grapple. Every single time someone claims a float on the Float platform, their image goes up through the screen. And that's because Grapple, which we're using, is reading events from the blockchain and broadcasting it to our website, all through events. So, yep. You're totally right. So Big E said, I've used the Flovatar Grapple thingy all the time to check sales data. Exactly. So it's super helpful for talking to the outside world. Now I do have to run here, which is why I'm sort of going so fast. But you can see that if we scroll down even more, what did I say about resource interfaces, right? They can stay in the contract interface. They don't have to move anywhere. And you can see that in our implementing contract, we don't actually have it, right? Because we kept it over here, which is totally fine. And the NFT, right? So the NFT implements INFT above it right here. And you can see in the implementing contract, we don't define our own like INFT and then implement it right here. We don't do that. What we do is we reference non-fungible token.inft. Boom, right here, because we need that specific type. Now, where things get a little more complicated, so look, then there's like a provider resource interface. You'll notice we don't have any of those because we don't have to copy resource interfaces. But where stuff gets really confusing, and this is where I have to sort of leave us off, is, boom, what is this? A collection, right? So this is saying we have to have a collection. Okay, we have a collection, perfect. But look at the types. Owned NFTs maps a UN64 to an NFT. Okay, but this maps a UN64 to a non-fungible token.nft. And remember why that is. It's because if the contract interface is telling us a type, it's referring to the type that's local within here. So this NFT type is referring to this NFT right here inside of the non-fungible token standard. So when we actually go to implement it to use this interface, we have to refer to the NFT that this one is talking about, which is this NFT. Okay, so that's why we can't just put this here, or we're going to get an error. We have to put non-fungible token to NFT. So in the next lesson, we're going to spend the whole lesson just talking about how to turn our NFT contract that we wrote into a contract that fits the non-fungible token standard. And then you'll have your own NFT contract that's official on the Flow blockchain. Even though it will be like locally on your computer, it will be an official NFT contract that you wrote. So that is the end of today's content. I really hope that was helpful as always. And if you have any questions at all, please just reach out to me or anyone else in the Emerald Academy. And yeah, we'll have our last bootcamp on Friday. Really sad, but also really exciting.